We are diving into a story of immense national pride, incredible technological ambition, and the very real dangers of pushing aviation to its absolute limits. And we're going to explore all of this through the lens of a single, tragic event at the 2025 Dubai Airshow, an event that sent shockwaves through the entire aviation community. So let's get right into it. We're not going to start at the beginning of this air crash story. Instead, we're starting with its most recent and most dramatic chapter, a tragedy that captured the world's attention. You know, this one sentence from the early news reports, it just says it all, doesn't it? It perfectly captures that awful moment on November 21st, 2025, when everything went wrong. A moment that brought one of the world's biggest air shows to a dead stop. So here are the hard facts. We're at one of the most prestigious aviation events on the planet. An aircraft that represents the very pinnacle of India's aerospace industry crashes. And tragically, the pilot, Wing Commander Namansh Syal, lost his life. The question on everyone's mind was immediately, what on earth happened in those last few critical seconds? Well, to answer that, we really have to dissect the anatomy of the crash itself. In the moments and days that followed, experts started this painstaking process, poring over flight data, analyzing cell phone footage, anything they could find to piece together exactly what happened. And one term came up again and again in their analysis, the oblique pull. Now, flight analysts pretty quickly zeroed in on this complex and, frankly, very hazardous maneuver as being key to the incident. You see, unlike a simple vertical climb, when you pull up at an angle, it becomes incredibly difficult, even for the best pilots in the world, to know exactly where you are in relation to the ground. And when you piece together all the available footage, a heartbreaking sequence starts to form. The jet does this high G-turn, it inverts to line up with the runway, and then begins that dangerous oblique pull. But the critical error, analysts say, happened right here. The pilot missed a crucial gate. Now, think of a gate as a tiny, invisible window in the sky, a point you have to hit at the right speed and the right altitude to pull out of the maneuver safely. He missed it. And even though the jet's nose was pointing up at the moment of impact, it was just too low and going too fast. There was no room for recovery. This quote from an aviation analyst really drives home just how dangerous this was. He pointed out that while this wasn't technically a perfect barrel roll, the physics behind it are incredibly similar. These kind of rolling, oblique maneuvers, they are just notoriously unforgiving. And sadly, they have a very long, very dark history at airshows. So, we've talked about the how, but what about the what? What exactly is the HAL Tejas, the plane at the center of this whole story? To really get the full picture, you have to understand the aircraft itself. Okay, so the Tejas, which means radiance in Sanskrit. Well, it's way more than just another fighter jet. For India, it is the absolute crown jewel of their domestic aerospace industry. This thing is the result of a decades-long program, a sometimes difficult program, to build a modern, world-class fighter jet entirely at home. It's meant to be the future backbone of the Indian Air Force. And one of its most amazing features is its design. The Tejas has one of the highest percentages of lightweight composite materials of any fighter out there today. That means a huge chunk of its body is made of advanced carbon fiber. And that's what makes it so small, so light, and so incredibly agile in the air. The very things that make it so spectacular to watch at an air show. Which, you know, brings us to a much broader and much more sobering point. The crash in Dubai was a huge shock, for sure. But unfortunately, it's not some kind of isolated incident in the high-stakes world of aerial displays. This timeline, it's a really stark and tragic reminder. When you push these incredible, high-performance machines to their absolute limits for public entertainment, well, there's a profound and recurring risk. From the horrible mid-air collision at Ramstein to the absolute devastation at Skylab, the history of air shows is sadly marked by these moments where the spectacle ends in tragedy. So that brings us to the really crucial question, doesn't it? What does a tragedy like this mean for the future of the Tejas program? What does it mean for India's ambitions on the world stage? When you boil it all down, The story of the Tejas is really about this fundamental tension between promise and peril. On one side, you have this immense promise. It's a powerful symbol of self-reliance, a showcase of incredible technology, the key to a modern air force. But on the other side, you have the immense peril of working on the cutting edge, a world where the cost of pushing those boundaries can tragically be the ultimate human price. So, this incident really leaves us with a difficult, profound question. And it's one that has no easy answer. It's just a sobering reminder that every single leap forward we make in aviation is balanced on a knife's edge, forever caught somewhere between triumph and tragedy. To understand the story of the HAL Tejas, we have to look past the metal and avionics of the jet itself. It is a 40-year saga of Indian ambition, frustration, and ultimately, technological sovereignty. While the Tejas is often celebrated today as a symbol of Atmanirbhar Bharat or self-reliant India, its origins actually trace back to the lessons learned from a previous era. In the 1960s, India developed the HF-24 Marut, a beautifully designed fighter that was tragically underpowered. The Marut's prototype first flew on 17 June 1961, but was hampered by insufficient engine power, delivering only 7,200 pounds of thrust instead of the required 11,000 pounds of thrust. This led to a top speed of just Mach 0.93 instead of the targeted supersonic performance, despite 156 Maruts being produced between 1967 and 1977. The failure to secure a proper engine for the Marut haunted Indian aerospace engineers, creating a generational gap where the country became entirely dependent on Soviet imports. Specifically, the MiG-21, with over 870 units acquired from 1963 to 1984, formed the backbone of the Indian Air Force. By the early 1980s, those MiG-21s were aging rapidly, plagued by over 400 crashes and high maintenance costs, necessitating a replacement. This necessity gave birth to the Light Combat Aircraft Program in 1983, approved by the Government of India under DRDO. The Aeronautical Development Agency, ADA, was established in 1984 to lead its design with an ambitious goal, a 17.5-ton, single-engine, multi-role fighter. The initial timeline for the LCA was aggressive, perhaps too aggressive, with a projected first flight by 1990 and induction by 1995. However, the engineers at the Aeronautical Development Agency soon realized the magnitude of the mountain they were climbing. They weren't just building a plane, they were trying to build the entire ecosystem required to create a plane. The design featured a tailless delta wing with relaxed stability, fly-by-wire controls, and extensive use of composites. 45% of the airframe by weight was carbon fiber, reducing radar cross-section and weight to 6,500 kilograms empty, making it the lightest in its 4.5 generation class. The challenges were compounded in 1998 following India's nuclear tests at Pokhran, triggering US sanctions under the Glenn Amendment. This halted collaboration with Lockheed Martin, specifically affecting the development of the fly-by-wire control laws. These complex software systems keep an unstable fighter jet from falling out of the sky. Lockheed Martin, which had been consulting on the project, was forced to leave. This crisis, however, became the program's defining moment, forcing Indian computer scientists and engineers to develop the control codes entirely in-house. This feat, achieved by 2002 with over 2,000 lines of code, is today considered one of the Tejas program's greatest intellectual victories. As the program moved into the 21st century, the physical reality of the Tejas began to take shape, characterized by its distinctive delta-wing design. The first technology demonstrator flew on 4th January 2001, followed by Prototype 1 on 25th January 2001. It is the smallest and lightest distinct class of supersonic combat aircraft in the world, designed specifically for visual range dogfighting dominance. This dominance was a capability the MiG-21 used to provide, showcasing the Tejas as its spiritual successor. A key differentiator was the extensive use of composite materials, carbon fiber rather than metal, which makes up a significant portion of the airframe. This reduced weight and radar signature, contributing to its stealth characteristics. Despite these airframe successes, the ghost of the HF-24 Marut returned to haunt the propulsion aspect. The indigenous Kaveri engine project, developed from 1986, failed to meet the necessary thrust-to-weight requirements, delivering only 70 kilonewtons by 2008 instead of the targeted 81 kilonewtons. This forced a pragmatic but difficult decision to power the Tejas with American-made General Electric F404 engines opted for in 2007. While this meant the jet wasn't 100% indigenous, it saved the platform from obsolescence, powering the aircraft to Mach 1.8 and a 3,200-kilometer range. The journey from the first flight in 2001 to final operational clearance was long and often ridiculed for its delays. Prototypes underwent over 4,000 hours of flight testing across 5 prototypes by 2010, with initial operational clearance granted on 10 January 2011. Critics pointed to the shifting timelines and the continued reliance on foreign engines as signs of failure. Yet, the narrative shifted dramatically in the last few years, with full operational clearance taking until October 2018. The introduction of the Tejas Mark I represented a maturation of the platform, featuring modern SR radar and electronic warfare suites. It also included mid-air refueling capabilities, increasing payload to 5,300 kilograms and endurance to over 3 hours. A massive order for 83 of these jets, a landmark 48,000 crore rupees contract on 10 February 2021, signaled that the Indian Air Force had finally accepted the Tejas. Not as a science project, but as a frontline combat asset, with the first Mk-1 squadron inducted on 1 July 2016. Today, the Tejas stands as more than just a replacement for the MiG-21. It is the foundational stone for the future of Indian aerospace. The experience gained in aerodynamics, software, and materials science on the Tejas program is directly feeding into the development of the Tejas Mark II. The Tejas Mark II, a 17-ton medium fighter with GF414 engine, has prototypes slated for 2025 first flight. This also feeds into the AMCA, India's 5th-generation stealth fighter project, approved in 2019 with 15,000 crore rupees Phase 1. In a geopolitical environment where supply chains are weaponized and wars are protracted, the ability to manufacture one's own fighter jets is a strategic necessity. The Tejas took 4 decades to arrive, but its true value lies in the fact that it broke the cycle of import dependency, ensuring that for the first time in history, the guardian of the Indian skies is actually made in India.